Now, next topic is again very important: uh, relation between electric current, drift velocity, and the derivation of Ohm's law. So this is a big topic and very important one also. Now, imagine that you have a conductor which is connected to a cell. If the conductor is connected to the cell, that means there will be some electric field. You can see in this diagram. This is the conductor, and this conductor is connected to the cell. The cell is providing positive, negative charge, and the electric field is set up in this direction. It's a very simple electric field set up in this direction. Now, if the electric fields are in this direction, then these free electrons would be moving opposite to the direction of the field that you already know. Area of this conductor is A, length of the conductor is L. So this is the situation we have. Now we are going to calculate the value of the current flowing through this conductor. How to calculate the value of the current? Now, to calculate the current, I need two information. To calculate current, I need two information. Again, Q, I need to know the charge that has flown through this conductor, and I also need to know the time in which the charge that has flown. So first, let's find out the Q. Now, assume a certain time t. In the certain time t, if all the electrons that were here, in a certain time t, in all the electrons that were here on this one end of the conductor, in a certain time t, they crosses the conductor and reach the other end. So in a certain time t, they reach the other end. Now, if the electrons from this end has reached this end, that means all the electrons that is within the volume of this conductor, all electrons within this volume, visualize this correctly, all the electrons that is within the volume of this conductor must have passed through the conductor at any area. It must has passed through it. So I need to know how much charge all this electron that has flown from this end to this end, how much charge these electrons have. So be very clear what exactly I want to know. I want to know how much charge these electrons have. And which electrons? Which electron? The electrons that has flown. Okay, the electrons that has gone from this end to this end. So how to find that? Now let's find first what is the number of electrons in this volume of conductor. Number of electron in this volume of conductor. Now that value will be is equal to number of electron per unit volume, that is small n, into area into length. Now this small n is number of electron per volume. So there are two values, that there are two n here. One is the small n, and a capital N will always also be there. So don't get confused. Small n means number of electron per volume, and area into length is equal to volume only. So by doing this, n small n a l, what do I get? Number of electron. Number of electron in this conductor. Okay. So the number of electron here. Okay, is this clear? So number of electron here. Now I want to know charge on the electrons. This number, this electron. So charge on the electron, how much it will become? The net charge on all these electrons. It will become the charge times E. Each electron is carrying a charge E. Each electron is carrying a charge E. E N A L. That is the total charge or net charge is equal to charge of the electron into the total number of electron. Okay, total number of electron. So what do I get? The total charge Q is equal to ENAL, and that is the charge that has flown. Now again, what else do I need to find? I need to find the time. You see, I was Q by T. Q, now we know how much of charge has flown. So now we need to know time. Now, what would be the time? If the conductor, if the electrons are moving from this end to this end, that means they are covering a certain distance L, and they're moving with a velocity, drift velocity, Vd. That means the time they will take is the distance, that is L, divided by the velocity, that is Vd. Now Q you have already found out, and time also now you know. So your value of current will be Q by T, and Q is equal to NEAL divided by T. T is L by Vd. So I is equal to NEAVD. NEAVD. The L will cancel, and this Vd comes on the top. Now I is equal to NEAVD will give you a relation, direct relation between current and the drift velocity. Again, you see this makes sense also. If the drift velocity is high, that means more electrons are crossing the conductor per unit time, and more will be current. Now in this expression, you can then take I, and A you can take on the other side like this, the denominator, and it will then will become what? ENVD. ENVD. And I by A is current density J. So then you can also find the value of current density from here. Current density J, I by A. And then drift velocity is also a vector, current density is also a vector, you already know. So the same expression in the vector form will be J vector is equal to En, which is scalar value, into the current density, drift velocity. Now from this we can deduce Ohm's law. You already know what Ohm's law is. So we can deduce Ohm's law. And how? So you see, you have got the value of drift velocity as well. You have derived the value of drift velocity. So if I is equal to NEAVD, so drift velocity, you have found out drift velocity to be the charge into the electric field divided by mass into the relaxation time tau. Previously, I've found this out. So then I will be is equal to NEA, and this whole value will be here E, charge E, electric field E. Don't confuse between the two, divided by mass into tau. Now you already again know that V is equal to EL, or E is equal to V by L. So again your current I will become NEA. Again this E and this E both are the charge of electron, so you can remove it and you can just put a square term here, and this electric field then can be written as V by L into tau divided by mass. Now you can take this V here and put it on this denominator, so it will become what? I by V is equal to N E square tau A divided by ml. V by I will become N ml by N E square tau A. Now in this expression, you will find M is the mass of electron. What was M? Go back and see. M was mass of electron. L is the length of the conductor. N is the number of electrons per unit volume. E is the charge of the electron. T is the tau, relaxation time, and A is the area. All of them are constant. This is constant. Mass of electron constant, length of the conductor constant, number of electrons per unit volume of any conductor, that is also constant, charge of the electron constant, area of the conductor constant, and this here tau, is relaxation time. This is also constant at a constant temperature. At any given constant temperature, this relaxation time will be constant. Now, this relaxation time can change. Let's discuss a bit about this relaxation time now. You see, relaxation time tau is dependent upon temperature. How? What was relaxation time? It is a time between two collision. Between the two collision, the time, that is the relaxation time. So if you increase the temperature, the thermal velocity of these electrons will also increase, and they will take less time to do two collisions. So increase in the temperature will increase thermal velocity. Increase thermal velocity. Increase in temperature will increase thermal velocity and decrease relaxation time. So it will decrease relaxation time. This is very important to understand. If you increase the temperature, the velocity of this thermal velocity of this electron will increase, and the time taken for two successive collision, the time will decrease. In less time, they will do that successive collision. So increasing the temperature, the relaxation time decreases. This is important concept. Temperature increase, relaxation time decrease. So what we see that at a constant temperature, V by I is equal to ml by ne square a tau. And as we discussed here that the whole of this thing is a constant. This whole thing is a constant. And that is why V by I is a constant, and that's what Ohm's law is. That is what the Ohm's law is. Now in this very expression, you can see that this value here, this constant value, can correspond to resistance, because we have been calculating this whole thing with respect to a conductor. So we can then say that this is actually the resistance of this conductor. This is the resistance of the conductor. Resistance of the conductor means that it will have the value of this whole thing. So the resistance R will be is equal to ML by NE square tau A. Now you can take the L and A away from this, and then you can see this M by N E square tau into L by A. That is what your resistance. Now this expression here matches with this one. That means this value here is rho. What was rho? Resistivity or specific resistance. So this value here becomes resistivity, and resistivity is now is equal to what? M by NE square tau. So if you look closely, your resistance will become ML by NE square tau A, this value. Then L by A you separated out, and then you get the resistivity as M by NE square tau. So resistivity is independent of the dimension of the conductor, because resistivity depends upon what? Mass of electron over number of electron per unit volume, then charge of the electron and relaxation time. Okay, but it depends upon the number of the free electrons per unit volume or electron density of the conductor and relaxation time. Okay, so resistivity depends upon these two values, and because the relaxation time, this depends upon temperature. So what was this relation with the temperature? You see, resistivity is equal to M by NE square tau, and that this tau is dependent with the temperature. So if temperature increase, relaxation time decrease, and if relaxation time decrease, resistivity will increase. Okay, so when you increase the temperature, relaxation time, this quantity here, this decreases because less time to take for two collision, and this value decreases. This is numerator, so this here rho, this value will increase. And if this increases, rho increases resistivity. What is rho? This is resistivity. If this increases, then resistance R will also increase. So if you increase the temperature, that is going to decrease. If you increase the temperature, that's going to decrease the relaxation time. It's going to increase the resistivity, and it is going to increase the resistance as well. So resistance will increase. So increasing the temperature, resistance increases. Increasing the temperature, resistance increases. Now another very small topic here, the relation between the electric field, current density, and conductivity. So drift velocity is equal to minus of E charge electric field tau by M, and current density you will have NQVD. This we have done. So you can find a relation between, like you can do the relation between the current density electric field as current density is equal to conductivity times the electric field. So this relation again you can get. Okay, so Ohm's law in the term of vector quantity be like this. So you see, we have done this before, the vector form of that law. So these are the vector forms of this Ohm's law. This is the vector form of Ohm's law. cause of instantaneous current. Now, think about this, that we have just now done drift velocity, and we also discussed that the drift velocity value is very less. So drift velocity of the value is very small, and typically it is 1 millimeter per second. So it is very, very small. So how does it happen that when you switch on your electric bulb, and an electric bulb is lights up as soon as we turn the switch on? Why? This is because the electrons are present everywhere in the electric circuit. The whole electric circuit has electrons. And when a potential difference is applied to the circuit, an electric field is set up through the circuit, almost with the speed of light. So electric field is set up very fast. The electric field set up very, very quickly. The electron in every part of the circuit begins to drift under the influence of this electric field, and current begin to flow in the circuit almost immediately. Okay. So electric field set up very quickly because electron is there everywhere throughout the circuit. Circuit means your switch, your wire within the walls of your house, the wire going through the lights and bulbs, fans. Throughout the conducting work channel, the conducting path, electrons are there. When you switch on, then the electric field is set up quickly, and due to that, the electrons would start moving. All of them will start moving, as because all of them start moving, current becomes to flow instantly.